Hey, what's up, guys? So this is going to be another project using Bluetooth Low Energy. This time we're going to control WS2812 addressable RGB LEDs through an Arduino, but all of the color information is going to be sent wirelessly from a smartphone app. And I'm going to walk you through how all of this works, and it's actually a pretty simple project. But first, let me give you a quick demo and just kind of show you what's going on here. Okay, so I killed the lights there so you could see the LEDs light up a little easier. But from the app, we basically just have three sliders, and I'll show you a close-up of the app here in a second. But we have three sliders, one for red, one for green, and one for blue. And we can mix and match these three sliders to make up any value we want for the RGB data going to the WS2812 LEDs. And you can see as I slide these, it updates the LEDs in real time. So the inspiration for this whole project actually, and I'm not finished with it by the way, but the inspiration came from these cheap LED strips that I've got all over the place here that come with these crappy little remotes, and you don't really have a lot of options for colors or animations. So I'm going to create a project that allows me to connect to any of the strips. So I'll have some kind of selection down here to choose which strip I want to connect to, and then I can set the color or the animation type or anything else that I want to control. So that is the app. Let me give you a quick close-up of that real quick. Okay, so when you look closely at the app here, you can see that we've got a little preview of what the color should be, and that's updated in real time as well, and it's rendered right there in the app based on these RGB values. Okay, we also have an event log down here, which is just showing us any serial information that was sent from the Arduino back up to the smartphone. And that's a carryover from the last project I did, where I showed you how to use a software serial interface to communicate from the BLE board to the Arduino. But anyway, there's another thing I added here, which is an auto connect feature. So now when you launch the app, or when you come within range and you open the app, it will automatically connect to the BLE board. So no more needing to go to a scan screen and then select the device. None of that. It's all built in, and as soon as you launch the app, it automatically connects. So I'll show you how all that works as well. But that's pretty much it. The other thing too that's cool is as I slide these, the data is printed out from the Arduino. Here's a serial monitor window. So we can see the data in real time as I'm changing it. Okay, so now let's break down everything you see here. Okay, so what we've got here is just a dead simple setup. We've got a standard Arduino 2 it's the same thing as the Arduino Uno. The WS2812s are hooked up to the Arduino. Each one of these in a panel are connected in series, and we've got 45 of these LEDs. They are powered externally since they can pull, let's see what they pull at full tilt. They pull 2 amps. So 45 of those LEDs pulls a little over 2 amps at 5 volts. Okay, so not going to be able to power those directly from the Arduino. But I've got those hooked up or powered externally there. The ground is tied to the ground of the Arduino. And everything here is running at 5 volts again, so we need level shifters going over to the BLE board. And that's what this little piece here is. This is just a little board with a couple level shifters and a 3.3 volt linear regulator. Again, we have a software serial interface, so the TX and RX signals are level translated. They're hooked up exactly the same as the last video, but I'll just give you a quick rundown there. So we've got P32 and P33. So these are our UART signals. RX from the BLE board is connected to TX on the Arduino, and TX from the BLE is connected to RX on the Arduino, and you'll see that in the code as well. One other thing I just want to show you, if you go to the power cheater board, you can see the full breakdown of what this little level shifter board is. So you've got the schematic here and how those level shifters work. I even have a video showing you how those level shifters work. There's a parts list in here and everything else you could want to know about that board. Okay, so very simple. And yeah, that's all there is to the hardware. So let's jump now into where all the magic happens, and that is in the code. Okay, so just one other thing to it in case it wasn't clear. I was also powering the board, the BLE board, from this little power cheater board, so that's got the little 3.3 volt regulator. But of course you could power it from the Arduino's 3.3 volt output as well. So anyway, just a quick note there. Now the code running the BLE board and the app is right here, and it's a pretty simple program, and a lot of this was reused from the last video where we're doing the UART read and the UART write. Okay, I added more functionality in down here to handle the auto connect, and then the slider control is right here. So I don't know if this looks like a mess to you, but it's actually pretty easy, and once you kind of see how it all works, it'll make sense. This might even be a little easier to read than raw code. So anyway, let's jump right into this, and then we'll switch gears and go to the Arduino and break all of that down. So okay, so I'm not going to go over what all of this does because we already covered that in the last video, but basically this handles the UART read. So this is displaying the stuff that is shown in the event log right here. So whenever the Arduino sends some data up to us, we do a UART read on it, and we've got this polling task. And I did slow that down, so now we're only polling it every 1 second. So that's what this does, and displays it in that window there. And then when it hits, I think 3 or 4 lines, we clear that window out. Okay, so that's all that does for us. So the next thing I want to talk about then are these sliders. So I've dragged over some sliders. You can see those were elements right in the toolbox there. Drag those right on over. So we've got 3 of them, run for red, blue, and green. And by the way, if you import this, and I will have this this project available for download, but if you import it, I think it comes in and this all looks mashed up like that. And that's because you need to go over and select your device, which I'm running an iPhone 5 on. So you can create new devices and lay them out however you want. But anyway, yeah, we've got the 3 sliders there. And then we've got this image up here, which is used to show, you know, the color of the LED. And what's actually cool about this is that it's a PNG. I imported it right in. So when you drag an image down, you can upload it in. And the background is transparent. So what I'm doing is actually changing the background color. So you can see that it's a see-through circle where the outline of it is all white. So I'm actually changing that background color to show, you know, the color of what the LED should be. Okay, and then we have the raw color display right underneath that, and then the UART write. So there's a lot going on here. Well, I shouldn't say a lot going on, but a lot of tests, you know, at first, because I was really trying to figure out the best way of doing this, because, you know, you have a lot of different triggers when you slide these sliders. When you grab those, you can activate things whenever it changes. So if you did it that way, you know, you're basically blasting the UART. So with a ton of data, and it's responsive, but if you sweep these back and forth very quickly, you're going to build up a huge buffer, and it takes a while for it to finally catch up with it. So what I did instead was add a task here that runs every 50 milliseconds to basically, when you are sliding these around, to send the new information, whatever the slider values are at, every 50 milliseconds. And you'll see how that works here in a second. But anyway, that's kind of the system architecture and kind of how it works. And then this whole mess of getting the auto connect working, we'll talk about later. Okay, so we've got the sliders in, and those sliders all feed an expression. And this is something kind of cool that I found. You can actually write straight up JavaScript functions in these expressions. So, and that's what I did, and I'll walk you through with that as well. But that was something kind of cool that I found you could do, because I needed to take these 3 values and basically combine them into one value to be used by both the background color for this LED that's on the screen, and also one value that can be sent down to the UART. So that's what this expression does. So you see here that if we just look at one of those connectors, we see that anytime the event is changed, it gets the value from the slider and it adds a value. So it's adding a value for this expression to use, and its key is going to be red value, and of course we're going to grab the value of the slider. So we have one for red value, we have one for blue value, and I have these backwards. Let's move that back up. Red, green, blue. And so yeah, that should be green. Oops, grabbed the wrong one there. So then that one's green value, and then this one is blue value. Okay, so we've got those three values, and anytime the slider changes, it's sending that value to the expression. Okay, and then you see that there's a second connector there going down to the task. And we have two triggers here. So anytime the mouse is released, so that's your finger letting go, we want to pause this task because we don't need to send data if the slider's not moving. When you press in, when you grab that slider for the first time, we have a trigger for that, which is to run it. And of course, we're running it at 50 milliseconds. And that same trigger is for any of these sliders. So any of them, anytime you grab them, it automatically kicks up this task, which then it starts the evaluation of this expression. So every 50 milliseconds, we're executing this expression. So this now has the three values from these sliders, and then the task every 50 milliseconds will actually run the expression. So hopefully that kind of makes sense. Okay, let me go over to the expression now and show you this code. So I actually found some of this code online already, but this is how you set up these functions. And basically what we have in here, and one thing I want to do real quick just to make it a little bit easier. Oh no, it's okay. So I've got a return variable here. So I've called it variable, and hopefully you can see that in the video. But we're creating a variable, and if you can't, just import this project and look it over for yourself. But we've got this variable in here, and we're creating this RGB value. So we started with a hashtag plus the values.redValue to string with a format 16. So that's converting it to a hexadecimal number. But I'm also converting it to a string so that it forms this entire string. So it'll be like hash 00FF00, right? And that's kind of what I'm doing. So you see the red values, or the red value, the values.blue value, same thing. Or I skipped over green there. So you got the red, the green, the blue, and it builds up this entire string for you and then returns that value. So that's the output from this expression. Okay? So then the output from that expression goes over to the LED image. So anytime that's been evaluated, since the task will trigger that evaluation, and then after it's evaluated, it will then get the value and set the background color for the LED image. So that's how that works. And then the label is the same kind of thing, except now we're setting the value to value, and it displays that right underneath the image. And then finally, we do a UART write. So same thing, when we're evaluated, we get the value, we execute that UART write function, we pass along the value. But again, when we go down to the code view for that UART write, you'll see that, well, I'm also flashing the LED here, but I'm also doing an sprintf here to now take the data that came in, put it right here, but also add a new line feed character to it. Okay, so down on the Arduino then I can catch that data and read it until I see the new line character. Okay, and then we do the UART write. Okay, so that's pretty much all there is to it. You know what I think I'm going to do? I'm going to jump over to the Arduino code real quick before we talk about that auto connect functionality. Okay, so here's the Arduino code, and there's really not a lot going on here. It's pretty simple. So you see we still have the software serial code, it's all the same stuff. So you see TX pins on 3, RX pins on 4, and again, RX pin from the Arduino is TX pin on the BLE, and the TX pin goes to the RX of the BLE. We have a string here from BLE, so that's going to be the data coming down. Then we have the 3 bytes for the color values, red, green, and blue. And then I've got this converted BLE string. So after, we get the raw data coming in, we have to convert it. And you'll see that in a second here. All of the WS2812 code, all of that has been copied from another video I did on the WS2812. So check out the description below for all of that, because I'm not going to go through that code again. So it's just a copy and paste job. And we're running the WS2812s on pin 8. And again, right now that code only supports pin 8 right now. Okay? And so I copied and pasted all of that right in here. And then the function right there, the driver function, is down here, pasted right in at the bottom of this. But really there's not a lot of code here at all. So, okay. So then in the setup, we're running the software serial interface to the BLE board at 9600. And if you go to project settings here, you'll see that I changed this now to 9600. So I slowed it down a little bit. We've got we're running the hardware serial so that just for debug purposes at 115.2. And okay, then of course we set the output pin for the WS2812. And then in the loop, there's really not a whole lot going on here. What we're doing is continuously checking to see if new data came down from the BLE board. So if it did, we clear out that string and we want to read until we get the new line feed character. And then we trim out all the white space and junk we don't need. And then I do a serial.println of that data. And I was showing you that before, so check it out. I'm actually sweeping those sliders right now, and you can see the raw data coming in. And well, that's pretty bright. Let me turn that down a little bit. Okay, it's better. Okay, so we print that out just for debugging purposes. And then what I want to do, just in case the data got garbled up or something fell out of sync, is I want to check to make sure that the first character is a hashtag. Okay, so and if it was, then we continue on grabbing the data. But if it wasn't, flush out the serial interface buffer. Okay, and then it basically starts over. Okay, so here's the next thing, and I found this out. This is kind of a cool thing. So what we have now is something that looks kind of like this. It's like 0, 0, and it's all the RGB data, right? So that would be green at full intensity, right? Or it's highest brightness green. This would be all off, and then this would be for all the blues. But anyway, this comes in as a string. And we need now to convert this FF into a 255, which can be read in now from the, that can go down to the WS2812s. So that's what this does. So this will take in now that from BLE string starting at 1, because we have the hash out front, starting at 1 with the format as a hexadecimal value. And it will actually convert all of this to string to long for us. So this is kind of cool, and I didn't actually know that this existed. But then what we can do is then take the red, green, blue data out of that converted string, and you can see we're just shifting everything down. So the red is shifted down 16 places. The green is shifted down 8 places, but then ANDed with a double F. And then, of course, the blue is already in the 0 position, so it's just ANDed with the double F. So anything that's above that, because this comes in, as a long, a 32-bit value. Okay, so anyway, one of the things, too, I forgot to mention is that these sliders are not all resting at 0. So if you look here, what I'm doing here is setting all of these to 16. And the reason for that is so that this expression here, this code, and I'm sure there's an easy way to do this, but it's just an easy way for this code to work, since it's going to always be let me go back to this format. It's always going to be double values here. Double value there, double value there, and double value there. So if I didn't have it at 16, you know, I could have a situation where I just have 3 values like that. And it makes it a little bit trickier for it to then figure out which is the red value, the green value, and the blue value once it's then passed along to the image, the raw color, and even the UART right. So what I'm doing is actually resting these sliders at 16 so that I always have a double value. Okay, so they're always going to be sitting like this. In fact, if I go up here and then bring all these down to their resting position, there we go. Nope, not quite there yet. There we go. So actually it's 1 0 1 0 1 0. Okay, right, because that is 16, 16, and 16. So we get that nice double value for each of the values. And that's why down here, if any of those are equal to 16, just make the red BLE value, the green BLE value, and the blue BLE value all 0. So that's my 0 position. So you'll lose some of the resolution there. Eventually, I'll figure out an easy way to fix that and do it right here so that it always adds in that extra 0. Because again, what I really want it to do, so if I had a value of 111, I want it to be like that, okay? But the code right now cuts it out and presents that, and which is a problem right now in the code. But anyway, that little tiny bit there, the 16 counts is really hardly anything noticeable anyway. So, okay, so then what we do is then set up the RGB array that goes down to the WS2812 LEDs. And again, I'm not going to get into this too much, but what we're doing here, since we're setting all of the LEDs, what I can do is set the RGB value array with the values first before we update the entire thing. So, you know, of course, you could loop through and go through and update every single LED and, you know, do a for loop with this. But it's easier to first update the array and then update all of the LEDs at once you update the array, and then just set the LED value to -1, which would be out of bounds for that function. So when you go down here, it would be out of bounds for that function, and then skip over the part where it then figures out where the LED RGB values should be. Okay. Again, all of that's covered in the other video, but that's how it updates the LEDs, and then that's it. Okay, so that happens pretty quickly as you update the sliders. And then finally down here, we just have a little thing here that every 2 seconds it does a print counter value up to the BLE board from the Arduino, and then increments that counter. And then we've got this little, and then we restart the start time, so that kind of just whatever's going on up here doesn't really matter. It's just every 2 seconds it will print that out. Okay, so anyway, that is the Arduino code. The last thing I want to talk about real quick is this auto connect feature, which is really cool. Okay, so we know we can get the connection status here, right? So this right now, and I've got a label down here that shows the connection status, and it when we click the trigger, or the connector, we can see all of the triggers, and we can set it for, you know, connecting, disconnected, disconnecting, or disconnected. But what we can also do is whenever it's disconnected, start scanning again automatically. And what this is actually doing, so I'll walk you through all of this, and it looks kind of confusing, but it's actually not too bad. So when it's disconnected, and we've got a little task in here that starts, and then you can see here, when disconnected, it will run this task once a second. Okay, the output of that task goes to the scan element, which starts the scan. Okay, as soon as, let me click the output of that. As soon as it started scanning, go ahead and pause the task there. Okay, so it just kind of adds a little bit of a delay here for everything to kind of work in sequence. Okay, so then it just pauses the task there, and now it's actually scanning. And when it discovers a device, I'll click this right here, the output of this. When it discovers a device, it will get the value from it, and we want to grab the name. Okay, so we're going to have a key of name. We're going to add that value, and it's going to be the name. You can see we have a source of name. And that name actually corresponds to the name you put in right here, which I believe can only be up to 8 characters. So I have the name right now set to WS2812. We also add a value for the address. Okay? And then the final thing we do is evaluate this expression here from that connector. Now, I found that it's important that this should be last, your last trigger. It's almost like these happen in order. I'm not 100% sure that that's true or not, but I thought that maybe, I had this trigger up higher, and it was evaluating without passing the name and address along. So anyway, just from now on, I'm always making sure to put the evaluate trigger last. Okay, so then that kicks off and then goes to this expression, which is very simple. Values.name double equal to WS2812. Okay, so now if that's true, we have a couple connectors outputting there. The first one that comes back around to the scan element, if it's true, stop the scan because we're done scanning. We found our device. We also have one that comes up here from the expression up to the connection element, and if that's true, we want to connect to that device, but the only thing we can pass along to it is the address. So values.address, and it will connect to that device with that name. Okay, and then the last thing we pass along here is found device to the connection label when that's true. And I think that's it that is passed along from that. I also have a connector going from the scan element back to the connection label as well, to show that we've started the scan and stopped the scan when scanning is stopped. So that's just a little bit more debug information. Okay. So that's kind of how it works. And of course, when it's disconnected, it will then start that task again, and which then kicks off the scan element. Okay, so hopefully all of that kind of makes sense. Once you kind of work through all these connectors, I think it's pretty easy to follow. But that's everything there is to it. So I'll make sure everything you see here is available in the description below. So feel free to import this into your project, modify it, play around with it, and do whatever you want. But again, this is just building up to a much larger project, as always, but I thought I'd break it down into smaller mini videos here showing you how things work as I move through it. I guess the video is not going to be so short anyhow, but anyway, that's the video. Hopefully that helps. Thanks for watching.